We can use all of the factoring methods from the previous lessons to solve some polynomial equations. So, not just like a polynomial itself, but like maybe where is it equal to some number. To do this, we're going to use the zero factor property that says that if the product of two things is equal to 0, it must be that A is equal to 0 or B is equal to 0, or possibly both. So if I want to use this property to solve this equation, what I need is, first of all, I need a product. And also, on one side of my equation, I need 0. And currently, we have none of those things. So what I'm going to do is subtract 56 from both sides as my first step. So I'm going to take this equation and rewrite it as x squared plus x minus 56 is equal to 0. So again, all I did there was just subtract 56 from both sides. Now, if I look at this expression and I want to use this property, again, I have 0, that's good, but I don't have a product. I have a sum and a difference. But perhaps we can take the left side of this equation and write it as a product. So x squared plus x minus 56. If I want to write this as a product, I would have to have an x and an x. You'd have to have a positive and negative term. And now I need two numbers that multiply to negative 56 yet add to a positive 1. So I'm going to use 8 and 7. The product of a positive 8 and a negative 7 is definitely a negative 56. And the sum of a positive 8 and a negative 7 is a positive 1. So clearly this thing is the factorization of this trinomial. So how does this help us? Well, if a product is 0, then these pieces, this piece and this piece, have to be 0 as well. So I'm going to take x plus 8, ignore the x minus 7, and set this equal to 0. So as my next step, I'm going to break this apart into, well, where's x plus 8 equal to 0? If this thing equals 0, then the product of these two things is 0, meaning whenever this happens, this is a solution. Also, x minus 7 has got to be equal to 0. These are two very easy equations to solve. I can subtract 8 from both sides in the first one. I can add 7 to both sides in the second equation, and this actually gives me my solutions. X is equal to negative 8, and x is equal to positive 7. Those two numbers you can check in the original equation, and it's going to make the left side equal the right side. So to recap, let one side equal 0, and try to write the other side as a product, and then check to see where each product itself equals 0. Let's try this idea in negative 3x to the fifth plus 3x to the fourth plus 168x cubed is, and I meant to write equal to 0. All right, so where does this thing equal 0? We've already factored this in the previous lesson, so I want to go through this just a little bit more quickly. What we did is we took out the greatest common factor of 3x cubed, and we brought out the negative as well. When we did that, we got negative 3x cubed, and what was left over was x squared minus x minus 56. And this is equal to 0. So all we're doing is taking this side of the equation and factoring it apart. You cannot factor the negative 3x cubed, so what we did is we factored the x squared minus x minus 56, which is really closely related to this expression here. The only difference is I want a negative 8 and a positive 7. That is, you have negative 3x cubed, we have x minus 8 and x plus 7. So to solve this very complicated equation, we factored it, and we can focus on 3 smaller pieces. This rule, the zero factor property, it only has 2 terms in it, but you could have 3, 4, or 5 terms. If any of them are equal to 0, then the whole equation must be 0. So by that I mean, if I focus on x plus 7, I'm going to set that equal to 0. And if I subtract 7 from both sides, I get one of my answers. That is, x is equal to negative 7. If I take x minus 8 and set that equal to 0, I'm going to add 8 to both sides, and then I get that x is equal to 8. That's another solution. 8 works, negative 7 works, but I also have this, negative 3x cubed. I can set that equal to 0 as well. Where is that equal to 0? If I divide both sides by negative 3, I get x cubed is 0. And there's exactly one number that makes this equation true, and that is x is equal to 0. If you ever have an x all by itself, it's got to be that the answer is 0. That's the number it makes it equal 0. It doesn't matter if it's cubed or to the 4th or to the 100th. If there's an x all by itself to any power, the solution for that piece has to be 0. Anyways, this equation has a total of 3 separate solutions, and the approach was to completely factor this side of the equation, and then from there, figure out where each part is equal to 0. In example 2, I just want to try a couple more problems of solving a polynomial equal to 0. So we have 100x to the 10th plus 1600x to the 8th. We've factored this one before, so let's just kind of quickly go through that one again. The greatest common factor was 100x to the 8th, and what was left over was x squared plus 16. Now what we found is x squared plus 16, that can't be factored any further. And this is the best that we can do. So what we're going to do is take both pieces and set them equal to 0 and see what happens. When is 100x to the 8th equal to 0? And when is x squared plus 16 equal to 0? As we said before, in the first equation, you would divide both sides by 100 if you wanted to. That leaves you with an x to the 8th. But really, there's only one number that makes that thing equal to 0, and that is x is equal to 0. So that's one of our solutions. For this other equation, it's going to turn out that there are no solutions to this. Here's one way to think about it. X squared is always positive. And if you add a positive number to 16, there's no way that thing could be equal to 0. So if you have like x squared plus a number is 0, like nothing can work. But you could also try to solve it. You could say, well, yeah, I'll subtract 16 from both sides, and that gives me x squared is equal to negative 16. And you could stop here too. There's no way you're going to square a number, a real number, and get a negative value back. If you wanted to take this further, you could take the square root of both sides of your equation, but even doing so would give you an error message and so on a calculator. So what I'm going to say is there are no solutions from this equation. There's no solutions. And what that means for us is this original equation has exactly one solution. That solution is 0. This thing gave us nothing, and that's it. Okay, let's look at this very last one here. So again, this is one we've factored before. Going quickly through this, we could take out a 7 and an x to the power of 2. And what was left over was 6x squared plus 17x plus 5. And our trick was to take the 6 and the 5 and multiply that to 30. And note that you can break that apart into a 2 and a 15. We split 17 into 2x plus 15x. And we went through kind of a lengthy process. But what I'm going to do is skip to our last step. So you can go to the previous lesson to actually see what the process is to get here. But the answer was x squared. And then we had 3x plus 1 as well as 2x plus 5. So to go from this step to this one, you can look at the previous lesson, and here we used a factored by grouping approach. Anyway, we're checking to see where this equation is equal to 0. I'll start with the 7x squared. I know the answer is going to be 0. We've talked about this a couple of times already. So 7x squared, there's exactly one number that makes it 0. That is x is equal to 0. Let's now check 3x plus 1. Where is that 0? If I subtract 1 from both sides, I get 3x is equal to negative 1. If I divide both sides by 3, I get x is equal to negative 1/3. I'll do the same thing for 2x plus 5. Where is 2x plus 5 equal to 0? You would subtract 5 from both sides in this equation. You would then divide both sides by 2. I'll leave my answer as a fraction, but it is x is equal to negative 5/2. So here we have 3 solutions. X equals 0, x is equal to negative 1/3, and x is equal to negative 5/2.